Good morning, Calculus. I want to briefly give you a, like I ever do anything briefly, give you a look at the fundamental theorem of calculus and why it's true. We've looked at equations and blah, blah, boring stuff. Let me give you a visual explanation that will hopefully appeal to your sense of logic and reasoning. That is my goal for this. So what I have here is, let's see, we had the fundamental theorem of calculus. It was the d dx, the derivative of an integral from a to x of some function f of t dt, and we say that equals the original function. That's what the fundamental theorem of calculus says. Basically, in another way, saying that they are inverse operations. They cancel each other out. Like if you have x plus 1 equals something, you subtract 1. Inverse operations, they undo each other. So this idea of the fundamental theorem of calculus is that the area and the derivative will undo each other. But let's see how that would actually work. So what I have here in the fundamental theorem of calculus, it has that starting value of a. That's what this line is. So a right now is, oh, let me see, it's different things on here. It's that 0.81 value. I should change that to an a. Oh, well. So that's a 0.81, and the value of x right now is at 4.56, and x is a function, so we can change the value of x. You can see that gives me a graph. That graph is of the shaded area. So at this point, the total shaded area is about that much. And what is the, so it's at 0.57. So you can see, let me see, the area here is increasing, and it reaches a maximum there, and then I start to add this negative area down here. So that makes that value go down. So I'm adding negative area, makes the value of the graph go down. Very depressing. Okay, we get back to 0, and then I'm starting to add some positive area to it again. So it starts going up. Okay, well, that was only for one particular value of a. Let's try another value of a. Let's try another value of a. How about right there? And then I get a different graph. And again, this graph is graphing the value of the shaded area for that starting value of a. So let's do a couple more versions of this graph. How about right there? And you should be noticing that these graphs are just a vertical translation of each other, just moved up or down a little bit. We get a couple more on there, and then we'll see, we'll try to think of its derivative. Okay, and one more. I want to get one right in the middle. Whoops, why did I try to drag that? One right in the middle there. Beautiful. There we go. And there we go, and there we go. Awesome. Okay, so let's look at the derivative of these area graphs. Let's look at the derivative of all these area graphs. Well, one thing we should hopefully notice is that the derivative is going to be the same regardless of the starting value of a. It's just moved up a little bit. So I can see that on this graph, the derivative of 0 is right there, that horizontal asymptote. The derivative is 0, the derivative is 0, the derivative is 0, the derivative is 0. All of the derivatives are 0 at this point. Okay, well, what's the value of my original function at that same value of x? Well, 0. So right here, where the original function had a value of 0, all of the graphs had a derivative of 0. So the graph of the area had a derivative of 0 when the function was 0. So the area graph, you take a derivative of the area graph, you just get the original function back. Here, when the graph is at 1, all of the area graphs have a derivative of 1. I have to be very careful with my words here. Over here, when the function reaches 0, all of the derivatives are 0. When the function equals -1, over here, all of the derivatives are -1. If I draw a tangent right there, you can see it's approaching a straight line, kind of. It's kind of a 45-degree angle, that derivative of -1. So hopefully you can see visually that the derivative of the area as it changes, it just gets you original function back. And that's kind of amazing. These seem to be unrelated ideas at first, but looking at it here and as we're working with it, hopefully it's starting to click with you that these are inverse operations, something that we might not have imagined until we started to get our hands into it. So that is just a visual help for you to understand what we're doing here in calculus.